In this video, I am going to explain how to verify the digital logic gates truth table with the help of waveforms in the proteus professional schematic capture simulation. So for that, first I have to place AND gate 7408 AND gate IZ. You may well known about AND gate truth table. This is a two input AND gate, both the input in high level, output in the high level. Okay, both the input suppose get a logic 1, the output also a logic 1. So we have to provide input, so that I have to place a clock as a input source to the two input. Okay, just I have to connect both the input with the clock. Then in order to see the output waveform, I place oscilloscope. So A channel I will connect one input, B channel I will connect another one input, output I will connect in the C channel. Okay, so the truth table of the AND gate is nothing but both the input are in high state, output is high. If any one of the input is low or any one of the input is logic 0, the output will be 0, logic 0. Okay, so I want to make this is 1 hertz, clock frequency is 1 hertz. I make it another one is in a different hertz, not 1 hertz. If it is not 1 hertz means the constant output will come, so that I make it the second input clock frequency as 2 hertz. Okay, let's see the response, what will happen. See, already we get the output. Just you have to make like this, then pause the response. Now we can verify the truth table. See, this yellow waveform is one input, this blue is another one input, this violet color is output signal. Okay, see here the yellow is this is logic 1, this duration is logic 0, this is logic 1, this duration is logic 0. Likewise in blue signal, this is logic 0, this is logic 1. See, compare these two input, this duration, the yellow is 1, blue is 1, logic the one input, the first input also logic 1, second input also logic 1, that's why the output is logic 1. So look at here, up to this duration the first input is logic 0, so that up to this duration output will be 0. In this duration, input 1 is logic 1, but the input 2 is up to here the logic 0, so that if any one of the input is logic 0 means output will be 0, so that in this duration logic 0. Let's see here, both the input are in high state, logic 1, so that the output will be the 1. Okay, only wherever both the input is high state, the output is 1. See here, in this short duration only, both the input high state, so that output gets 1. Here also the same. Rest of the region, any one of the input is 0, the output goes to low level. Okay, now we can verify the truth table of the AND gate. The similar way we can check the OR gate also. All the gates in similar way we can verify. So now I have to show you the OR gate response. OR gate is 7432. Place like this. Again, it is a two input gate. One input connected with the one clock source. The second also connected with the another clock source. So the output connected in the C channel. A channel input 1 I am going to connect. B channel input 2 I am going to connect. Okay, so already we fix 1 hertz in first input, 2 hertz in second input, so that straight away we are going to simulate this. We can get the response. So simply pass full screen, we can make pause the signal. Now we can check. See, if any one of the input is high, the output will be high. Both the input is 0, then only the output is 0. See here, this is logic 1 duration in the output. This is the logic 1 in the output. This is logic 1 the output. Only the short 2 period. In this area, logic 0. Output is logic 0. In this area, logic is output is logic 0. The logic 0 will happen in the OR gate when both the input is 0. So this short duration, you can check input 1 and input 2, both will be 0. Okay, this short duration, both the input is 0, so that the output is 0. The similar way, in this duration, both the input is logic 0, so that the output is logic 0. Rest of the region in the output is logic 1. Why? Because any one of the input. See here, the input 2 is 0, input 1 is 1. In this case, both input logic 1. In this duration, input 1 0, input 2 logic 1. In this duration, input 1 logic 1, input 2 logic 0. In this stage, both the input in the logic 1. So wherever any one of the input is logic 1, the output is logic 1. This is the OR gate. In the similar way, you can verify any of the gate with the help of waveforms. Logic 0 and 1, only the symbols, there is no meaning. The physical meaning is logic 1 means it is a high level, DC high level. Logic 0 means DC low level. Okay, so with the help of this waveform, we can show the discrete level. Accordingly, we can get the response of different gates. Wherever we are testing with the truth table, there's a 0 and 1s, only the symbols to understand. How we can provide the logic 0 and 1 to the physical circuit with the help of discrete waveforms only. So that I take this video how this waveforms make logic 1 and 0, how the response will come. I explain in this video. Thanks for watching. So you have to like this video, share to your friends, and also subscribe. Ask your friends to subscribe our channel. Thanks for watching.